Target. Determine the horizontal and vertical asymptote of a rational function. Rational functions, finding the vertical and horizontal asymptotes. First, we're going to try to find the vertical asymptote, first of r of x. Here we have the expression of r of x. The first thing we need to do to find the vertical asymptote is essentially find out where the function is undefined for x in the denominator. So we simply take the bottom one part of the function, set it equal to 0 and solve. We're left with x minus 2, x plus 2 equals 0. So this is where x equals 2 and negative 2. Now we need to be careful because we need to see the top expression also and see if that can be factored. In this case it cannot be factored, and the reason we want to factor the top one is we want to see if we can cancel out terms, which we can do in t of x. So here in this case I have a vertical asymptote at the line of x equals 2 and x equals negative 2. Now t of x, in this case I have the same, we know that this factors down because we just did it, to x minus 2 and x plus 2, but you notice in the top function this also can be factored, and that comes out to being x minus 2, x plus 2 and x plus 3. And you notice here in this particular case I have the ability to cancel out. So even though it gives me an undefined value of when x equals negative 2, it can be factored out. So this ends up, because it can be factored out, it's not a vertical asymptote, it's actually a whole, which we'll get into later expression. So this particular equation only has a vertical asymptote of at x equals 2. Here s of x equals this expression. We're trying to find, in this case, horizontal asymptotes. The way we do that is we factor out, we take these individual, and we factor out the highest degree term in each section. So for this one, the highest degree is the 9x5, so we need to factor that out. And down below we have x to the 8th, so we need to factor that through the entire expression down below. And this is what that resulting factorization gets us. And again, when I'm looking at horizontal asymptote, I'm looking at the long-run behavior of the function as it approaches infinity and negative infinity. So by factoring out this 9x to the 5th, you can see if I distribute it through back, I get to my original equation as well as that. But if I substitute in infinity for this expression, obviously this part becomes 1, this becomes 0 plus 0, and down below I'm left with 1 plus 0 plus 0. So essentially long-run behavior, as they both approach infinity and negative infinity, I get the same values. So essentially all I'm really looking at then is this front expression. And we know that 9x to the 5th over 8x, or 8x to the 8th, can be reduced simply down to 9 over x cubed. Roughly. So essentially this equation has a horizontal, mimics this particular expression. And to find out the horizontal asymptote, all I really need to do is long-run behavior, is find out the long-run behavior of this particular equation to see if there is any horizontal asymptote. In case we have a horizontal asymptote of at y equals 0 on the x-axis.